All right, let's go ahead and get started. This is Chris Brinton from Mosaic ATM. I'm the lead on this research project that we're doing, and I'd like to welcome everyone to this webinar that we're going to hold about trajectory option sets. Just want to introduce the team that we're working with for NASA under this research contract. In addition to Mosaic ATM, we also have AvMet Applications, and then Don Wolford has been working with us on this effort as well. And want to thank all of you that have participated in helping us get ready for this, and NASA for the support for this effort. We're going to talk today, and by the way, let me just start by saying these webinars sometimes can get bad audio quality if people have their microphones open. I have the ability here to mute everyone on the call, but you can then unmute yourself if you want to ask any questions. That being said, I also encourage everyone to use the chat feature in GoToMeeting to be able to submit any questions or topics, excuse me, that you want me to address during the webinar, and then I can work those in, and we will have opportunity at the end for open discussion. We have a lot of material that I think could generate a lot of discussion. So I'll try to pause at appropriate breakpoints to ask for comments and questions, but then I'll also try to keep that relatively controlled so that we can make sure that we get through all the material today. So we'll start by talking about an overview of trajectory option sets, and then we'll talk about what we're calling the clearable routes network, which is one of the main components that we're using in this research that we're conducting for NASA, and that we're looking to get your feedback and comments about this approach that we're using. And then we'll talk a little bit about integration of TOS capabilities into operations, and then finish up with some open discussion. So by way of background, this is a research project that Mosaic ATM is conducting under a NASA contract. The NASA contract has actually been going on. We're in the third year of this NASA contract, and it focuses on looking at decision support capabilities for the Collaborative Trajectory Options Program concept. Obviously, CTOP is not being used extensively in operations, and yet it is still an important combination of time-based and route-based traffic control with collaborative capabilities that provide a strong capability for both traffic flow management and NASA user needs. And there's a number of things that are coming out of our research related not just to CTOP, but also to the trajectory option sets in general and other aspects of measuring, predicting, and planning traffic management initiatives that we believe will provide some benefit in the industry and in operations. Some of those examples include looking at more generally congestion situations and weather situations that may require playbook and reroute planning, and airspace flow programs, and how the FCAs and reroutes may evolve for those programs. And then as well, some of the non-CTOP potential uses of trajectory option sets in other traffic management initiatives. And if I can also just mention as we go forward, I am going to give everyone that's attending here an email at the end of the webinar with a survey that will hope you'll fill out. It's very short, but I'll email that to you right at the toward the end of the webinar, and hopefully can get your comments and feedback then. So if there are questions or comments that you have that you're not able to share with us during the webinar, please take that opportunity to share those comments. All right, so before we dive into the trajectory option sets themselves, I want to describe as context setting 3 different models of interaction regarding flight planning that can be used between the flight operators and ATC. In today's paradigm, the operator files a single flight plan. ATC evaluates that flight plan and may accept the filed flight route or may provide a different assigned route. There are current efforts going on and ICAO concepts, including FFICE, for example, that use a somewhat different model where the flight plan can be filed in a trial mode, and a system on the ANSP side can provide feedback. So the flight operator would send in a single flight plan, and if that flight plan is unacceptable, the ATC system can indicate that as a response to the trial plan, but some constraint information can also be provided as feedback to the flight operator. The flight operator can then use that information to try a different plan. And we want to distinguish that then from the third model, which we've referred to here as a preference-based model, where in this model, the flight operators would actually file multiple potential flight routes, and the flight routes would indicate a routing preference from the operator, and then ATC would be able to use CDM allocation principles to be able to adjudicate and award the routes using equitable resource allocation. And in that process, then the NAS user preferences are accommodated to the extent possible, but the preferences are pre-specified by inputting multiple different routes. So it's important to recognize the differences in those models. The CTOP concept and the TOS, the trajectory option set, is the way to implement, is one of the ways to implement that third model where flight operators submit multiple routes and they can specify preferences for each of those routes. And we envision that this could be used not just for pre-flight, but in the future could also be used for en route, in-flight type of trajectory negotiation as a capability and as an information exchange mechanism between flight operators and ATC. That being said, most of the research we're focusing right now is looking at the pre-flight use of the TOSes. Here's an example of what a depiction of a TOS might look like. This is a TOS that has some of the additional data elements that may be unique to the CTOP implementation, but is the most established of the TOS implementations, if you will. At this point, you can see that there is a list of different flight routes, and then we have a map depiction showing what, if you will, the first choice, second choice, third choice of each of those routes would be. And the routes then are designed to go through one of the FCAs or a different FCA, where those FCAs may receive different rate controls. And so the flight operator is allowed to submit these trajectory option sets to allow then within the CDM-based equitable allocation a route to be awarded. But the flight operator expresses the prioritization via this relative trajectory cost in this left column, and then there are other aspects: required minimum notification time, trajectory valid start and end time, for example, that the flight operator can use to be able to distinguish and put constraints on some of the routes within those TOSes. But what we want to talk about primarily today with that as background is the research that we're doing on how to generate alternate routes within the trajectory option sets, and this is what we're looking for some feedback on. The Clearable Routes Network is a database of route segments in the National Airspace System that have been generated from historical analysis, and they include frequency of use of each of those route segments and other characteristics. And it's important that when we say route segment, we're really talking about smaller pieces of a route from one waypoint to another, not an entire route from origin to destination. And so with this CRN database, we can then use that in real time to construct routes that we see have been used, where the route segments have been used in the past. And because they've been used in the past, we believe then that the overall route that is generated will be acceptable to ATC because of the fact that those segments have been used in the past. So that really hits on the fundamental objective of the Clearable Routes Network, is to attempt to identify alternate routes and means of generating routes that can be designed to respond to dynamic and specific constraints, but that will still be acceptable to ATC and will not cause undue workload or rejection of those routes as they're filed. So we want to try to avoid suggesting routes that may be desirable from a flight operator perspective, but unacceptable to ATC, because that's not good for either ATC or the flight operator. But at the same time, we want to try to find routes that are both desirable and acceptable. And so we want to try to use this more dynamic search approach to be able to identify routes that may not exist, for example, in the CDR database or the playbook database or low altitude escape route database, some of those existing databases, or in existing flight planning systems that may be more static and not uniquely designed for specific constraints. So this is something, though, that we recognize may create some concerns or issues in terms of being more flexible in those types of routes that may be generated, and that's why we want to go through this and get some of your feedback. So, as I said, the CRN is constructed through analysis of historical route segments. So we look at the flights that actually filed and flew different route segments, where again those route segments are just from one waypoint to another. And then we include other characteristics such as the altitude, the aircraft type, and other things like that might tell us what the limits are on the use of that particular route segment. For example, if we happen to see that a given route segment from waypoint A to waypoint B is used only below flight level 240, then we wouldn't want to recommend that route segment as part of a route that might be used, that might be applicable above flight level 240, or when the request is for a flight that will fly above flight level 240. But our underlying assumption is that when constructing a new route, any route segment that was used with sufficient frequency in the past could be acceptable to file. And the important assumption here to point out is that this then assumes that we can use route segments regardless of where the flight is originating or flying to. I'll break for questions and comments here after I go through a quick graphical example of that, just to illustrate this a little bit further. So if you look at a case where you have a number of flights flying between airport ABC and XYZ, and many of them are using this route segment that's just from waypoint GHIJK to LMNOP. So that is a frequently used segment, and we've identified that in the CRN database. And now you have another flight that you're filing a flight plan for, and that flight is going from airport DEF to UVW, but it's going through an area of constrained airspace, and at this point now you are looking for an alternate route. The CRN then would use the route segments in the database, and it would identify that route segment, GHIJK to LMNOP, has been used frequently in the past. And so it makes the assumption, the CRN assumption is that it can be filed again. I see we've already got a comment in the chat window, which is a great question, which is time of day considered in one of the characteristics of the route segments? And I'll say that right now it is not considered in the version that we've implemented, but that is an obvious addition that would be very important to include. And I almost feel like we left it out on purpose to provide an opportunity for that to be a point of discussion here, and it's been nailed as one of the very first comments. So very good comment and good catch, and that's exactly the kind of thing that we're looking for. Is, are there other types of criteria that we should add in consideration of the CRN? But at this point, let me open it up and see if there are any other questions or thoughts that people have about it. I've unmuted all of you, so if there are comments, please feel free. If not, go ahead and just mute your phones. All right. Assuming not, we will continue on. Again, feel free to use the chat window if there are any other thoughts or questions. That works out great. But what I've got on the next couple of slides is some specific examples. And I'm hopeful that this will generate some specific thoughts or comments. We've tried to design some of these examples to be in an area of the airspace that many are familiar with, and that obviously also has a lot of congestion issues. So we're going to look at the New York area airspace. We're specifically looking at departures. And as I've noted here on the bottom of the slide, this CRN database we've generated from all flights from TFMS that we've received and archived from swim data. In this case, we used a data set from August to December of 2016. The database is generated through an automated process, so we can continue to update this, but it just so happens that the data that we used was from those last 5 months of 2016. And what you can see is that for departure routes, this is actually a toss that has been generated, a set of tosses that have been generated for flights where the constrained airspace is actually out in Kansas City Center. And I'm not showing that, but it invokes a number of different types of reroutes from these flights from the New York area. So for JFK, the routes included in the toss all go out over Cote or over Robbinsville. Now, there are other routes out of JFK in the CRN, but for a congestion problem where we're trying to route around FCAs in Kansas City Center, that was not necessary to exercise in this particular situation, and so that the CRN route generation did not search out and find those other routes. But you can see that the number of events in this database, so we have over 3,300 flights that we identified in the CRN database from this these 5 months in 2016 that flew from JFK to Cote. For the Robbinsville VOR, we have over 16,500 that flew from JFK to Robbinsville. So those segments, and then each of these other segments following on each of these routes, are identified as routes that have significant frequency of use. And so we automatically detect through the generation of the CRN that they're available for reuse. I've highlighted Phillipsburg here to be able to point out that in the database, we only identified 2 flights that actually flew from JFK to Phillipsburg. Now, there may have been others that flew to an intermediate location and then to another intermediate location and then flew on to Phillipsburg, but there was nothing that was of sufficient frequency of individual route segments that would allow the CRN route generator to generate any route that went from JFK to Phillipsburg, or for that matter, really any other way in between Cote and Robbinsville. So we do not include that Phillipsburg route or any other routes that you might take in between Cote and Robbinsville in the routes generated by the CRN. We added in Philadelphia, partially because we saw some playbook routes where there were some departures from Philadelphia up over Phillipsburg, but in fact did not see that exercised and did not see that in the data set. There were over 3,000 departures from Philadelphia to Medina, I think is the name of that fix, that nav aid. But there were none that went from Philadelphia to Phillipsburg. So again, we did not consider that in the routing. Now, the interesting thing though is when we add in Newark, and we looked at the operations out of Newark and looked at the routes that were generated for departures out of Newark. And we found that there was a combination of route segments that occurred frequently enough that the route generator was willing to generate a route that went out through Phillipsburg in this example. In this case, I'm going to show the counts of the different individual segments. So the lowest count you can see there is 67. And our threshold for this route generator that we applied here was 50. Now that's a parameter that's adjustable. And so, one thing to be done in the process of using and generating the clearable routes network is to identify what that minimum usage should be. And again, to apply the other criteria that might be appropriate, such as altitude and aircraft type. But in this case, we had 373 that went to Solberg, 105 that went to the next fix, 67 to the next fix, and then 523 all the way to Phillipsburg. Now, again, I want to point out here that each of these segments, the counts are measured individually. Because of the fact that we're not looking at origin or destination and where the flight actually came from, the 523 that went from SEG to PSB, these flights may have originated at other airports, but because of the fact that we are looking at whether this route segment was used in general to answer the question if it could be assumed that it can be used again, we're combining all of the usages of that waypoint, of that segment. So let me go ahead and break again there and see if there are questions or comments about what we've talked about here so far.
Hey, Chris, you have a couple questions on the chat you might want to look at.
Thank you. Yep. Okay. Um, so yes, one of the questions that we have here, since you're not going airport to airport, this would make it easier to not have to maintain the database, and also allow for GA who are normally excluded from the using CDRs. That's exactly right, and that's one of the things that we'll actually point out later. At the question of, well, what's the benefit of this? What are the reasons that one might want to use this CRN database? And maintenance is certainly one of them. And so because of the fact that this can be generated automatically from historical data, that is one of the benefits that we envision here, as well as the fact that the routes are uniquely designed when the constraint is actually known, rather than having to guess at what the constraint might be. All right, so next question. How do you envision getting to that protected segment? Just file to departure fix of choice that would get you to that segment. So essentially, when the CRN generates a route, it is going to generate a route that goes all the way from origin to destination. So even though we are not limiting a given segment to be used only for certain origins or destinations, when the route is generated, it is generated in the entire context of origin to destination. And so, as we saw in the JFK example, it used departure fixes because of the fact that the CRN found that the allowable and acceptable routes all only used those departure fixes. So it's an inherent part of the CRN approach to be able to get to that protected segment. In a sense, you could think of it as every route is made up of individual segments of the overall route that come from the CRN. All right, next question is, do you use the NRP rules for route generation? Great question. We have not applied those rules for route generation above flight level 290. That is definitely something that we could add appropriately to this capability. The pitch and catch fixes obviously are ones that need to be factored into the routing there, and I guess I would say that through this CRN process, one of the things that we are potentially trying to do is identify. I haven't really thought through this very well, so I'm speaking somewhat contemporaneously here, but we could identify pitch and catch locations that may still be acceptable to ATC, but that have not been specifically identified. Again, based on this principle of looking at specific usage of what has happened in the airspace previously. Again, speaking somewhat out of turn right there. So we'll have to think about that one a little bit more. And let's see, another question here on the chat window. Might a high count for a route segment indicate that it is saturated? So that's an interesting point, kind of to draw out the question of, and the distinction between generation of the routes versus allocation of access to limited capacity. And so while, yes, I definitely agree that a high count for a route segment may in fact indicate that it's a heavily used and potentially saturated route segment, it still would be a route segment that may be appropriate to use within a TOS, whereas then there would be other routes within the TOS that would provide the opportunity for a flight to be able to provide options to the air traffic control system to say, I'll take this route, but if it's congested, then I'm willing to take this other route. What is the time bound used for determination of frequency? So in this case, we are simply using the total count of flights that filed and flew those routes during the last 5 months of 2016. So these numbers that I've got up on the screen are showing the total number that use those route segments during those 5 months. And as has mentioned, was discussed earlier, in terms of the time of day or night, it's certainly possible that all 523 of these uses of this route segment occurred at 2 a.m. Or in the middle of the night otherwise in this time period. And so that is, one of the areas I think of most important feedback where we're going to go back and reevaluate that so that when routes are generated, they can be generated with that context. But that's also one of the other reasons that I included the number of route segments or the number of occurrences, for example, for some of these other fixes that we looked at, Robbinsville, for example, being over 16,000, to give you an idea of the scale of the total number of flights that are in there and that had impact. Great questions. Any other questions at this point? Okay. So this has been asked already in some degree about, some of the different rules that we've applied and what are the benefits of this approach. Obviously, the coded departure routes, as well as the playbook routes, these databases exist and are being used operationally to identify alternative routes that can be used. So why do we need something different? And as been mentioned before, maintenance is an important aspect of that. We believe that with additional criteria and constraints, if nothing else, this can be used as a capability in flight planning systems as well as in the ATC system to potentially support the development of the coded departure routes database and playbook routes in a more automated way. But we also believe that this can be used for developing alternative routes in real time to be used as part of a toss. Because again, we believe that the most important benefit is this first one here, is that when the clearable routes network is used to generate routes, it's done in real time with the knowledge of the specific FCAs or other congested areas that are being considered. And so because of that, we do not end up with, for example, routes that may go further up into Minneapolis than might be necessary to address a weather situation that may be located in the northeastern area of Denver Center or something like that. Now, obviously, there are many playbook routes, and so there are possibly other playbook routes that would be better designed for particular situations. But again, they are all designed beforehand, and whereas with CRN, we can dynamically design the routes in real time to be more efficient because they can go specifically around whatever the constraints are. And then because the CRN is automatically generated and not a manual database, we actually can consider even more routes than might be included in the coded departure routes. One of the examples that I just pointed out here in the slide is that, low altitude routes, tunneling escape routes, for example. I recognize that there are also databases and published escape routes to be able to get out of Dodge from many major airports, but the CRN may be able to identify additional routes in unusual or rare circumstances that may not be included in the database and may provide some benefit. So let's see. All right, another question. Would the CRN take into account any letters of agreement between centers? And that's actually a really good question, and one that, I'm hopeful that when you guys fill out the surveys, or if there's any other, thoughts or feedback, that you can provide some feedback to us on that. Because here's what I'm concerned about in some ways. To the extent that a letter of agreement between centers might specify that under normal conditions, aircraft going, this direction or to airport XYZ or whatever the case may be should go over a certain fix or on a certain jet airway or whatever the case may be. Obviously, those are beneficial and important in specifying standard operating procedure. The CRN and tosses and generating alternative routes around constraints may occur in situations where there are weather situations that may require adjustments outside of what is normally in those LOAs. So as a matter of fact, I guess I'll answer that question by saying we certainly could take into consideration LOAs and SOPs, but we've purposely avoided doing that because we don't want to constrain a situation where even the current ATC system does use flexibility outside of those LOAs. But with the CRN, we're trying to do it in a way that still increases the likelihood that what's going to be recommended is going to be acceptable to ATC. And actually, I'll talk about that some more in a couple of additional slides. Good question. Okay, what's the fidelity of the wind data used in generating these CRNs? Okay, and so there's two different parts of the CRN, right? So there's generating the actual database of which flight segments were filed and flown, and so we take that as an indication that they are likely to be acceptable to ATC. And then there's a question of actually generating an updated filed route that will be used for a specific flight on a specific day to avoid a specific constraint. With regard to actually generating the CRN database itself, I will argue that the wind data doesn't matter in that case, because the wind data that's actually going to apply when the flight is actually flown is going to be naturally different than the wind data that was in place when the historical event occurred. Now, certainly the usage patterns may be different if the jet stream is north or south or all sorts of different, reasons like that. But that's why we look over a very large period of time, and we use a threshold number of operations so that again, the assumption that we're making is that if there is enough usage, that route could be used. And then when we're actually developing the actual route to be filed for a specific flight on a specific day around a specific constraint, then the question comes into, well, what type of wind model, wind forecast is being used then to be able to figure out if a certain route through the CRN network is better than a different route. So in other words, we actually do not use wind models in the generation of the CRN database. And in our research, we are using wind models that are pretty rudimentary, but quite frankly, that's one of our research simplifications. If this were to be incorporated into an actual flight planning system, or other dispatch or ATC tool, that's one of the other areas that would need to be improved, is that wind model capability. But again, that would be specific to the generation of the unique flight for that particular day of operation. All right, any other questions before we move on? Thank you all, those are great questions. So one of the things that I mentioned just here at the bottom of this slide that we are also trying to identify is how accurate the routes generated by the CRN need to be before the overall CRN concepts become unacceptable. If it generates routes that are not actually acceptable to ATC 1% of the time or 2% of the time, is that okay to have errors at that level of frequency, or is the threshold for acceptability higher or lower or different? So correct. Right now, I'm sorry, the question is, are we using route miles for comparison and not wind distance? In our current generation of routes that we are conducting for the research, that is correct. We're using route miles, not time or a wind adjusted distance. However, in operations, that would not be the case. We would use wind adjusted distance if this were to be used operationally. All right. So stepping on to the last part here of the webinar, and again, thanks everyone for participating today. So some of the things that we envision as possibilities, and we've kind of alluded to some of these before, is that this clearable routes network could be used actually in combination with coded departure routes to be able to say use the beginning part of a CDR so that the more highly constrained process of getting out through a specific departure fix is maintained, but then beyond that, the CRN could be used to generate multiple different routes that could go into a toss, for example. And then also we're interested in the idea of looking at lower altitude routes, potentially for capping and tunneling, looking at different horizontal routes that might accommodate different periods of time and distance where the flight would remain low to be able to trade off an earlier departure time for that additional potential cost of flying lower or descending earlier. As I mentioned somewhat earlier, we have also looked at the FF-ICE concepts, and there are a number of demonstrations and explorations going on of FF-ICE to support trajectory negotiation. And the FF-ICE efforts, as we understand, are in fact looking at incorporating LOPs and SOPs, LOAs and SOPs, as we discussed earlier, as well as aeronautical information such as special activity airspace and those kind of things, and providing this opportunity for users to file a trial plan before making a decision, to be able to get feedback. FF-ICE, we believe, eliminates or reduces some of those limitations that exist right now in terms of not having some of the visibility into how the ATC system is going to respond to certain routes that might be filed. On the other hand, a couple of things that I think are important to note about the FFI's concept is that it seems right now that it uses the one in, one out model that we discussed earlier of the flight operator sends in a trial flight plan and then simply gets back some feedback regarding constraints and then has to refile a different trial flight plan to finally identify which route might be acceptable. So there may be some aspects of workload in that situation. And then there's also the question about how dynamic the application of LOAs and SOPs can be in situations where a flight operator needs to identify an alternative route because of congestion or weather or those kind of things. And would the LOAs and SOPs as encoded within FFIs be more limiting than might be ideal? All right, let's see. So we've got another question here. We mentioned PDRR and TOS usage. How would you leverage ABRR with TOSes? And that's a great question and is another area of significant research that's being conducted by NASA and the FAA and in a number of different projects, some of which we're involved in. I won't go into a lot of detail there, but I will say that we envision that if the flight operator were to keep the TOS updated as the flight becomes airborne and proceeds along its route, if the TOS is updated with current alternative routes, that could help to inform ABRR and inform the traffic flow management system and help to execute, again, getting back to the go button concept of the different routes that could be acceptable to flight operators airborne. And if those TOSes could be updated automatically by flight operator systems and evaluated automatically by the TFMS system, then you could envision that there could be more of a recommendation approach within the ABRR and the flight operator tools that would allow the dispatcher and the traffic manager and the specialist at the command center to evaluate opportunities and possibilities without potentially as much workload as might be involved at the current point. So again, I'm kind of answering that question off the top of my head, but it's a great question and one that we'll put some more thought into as we go forward in this research. Great. Okay. Will map exceedances associated with the CRN route options be factored in some way? So great question, and certainly it gets again to the question of the resource allocation aspect. Whereas when we look at just the TOS, we're looking at what routes are available that the flight operator could accept. The TOS then is an input to a larger traffic flow management program, one of which might be CTOP. As we talked about, there might be other traffic flow management programs that might use the TOSes. The CRN itself really does not address the map exceedances, the demand versus capacity, but it provides a tool within the context of that overall traffic management initiative where CDM resource allocation could be applied after the flight operator files the tosses then to be able to award routes and potentially EDCTs to flights such that the demand for given sectors and resources in the NAS do not exceed the capacity and even the weather adjusted capacity. That aspect is actually a very significant part of the research that we're doing under this NASA program, and I'd be happy to share separately some of the work that's been done in that area as part of this effort. But at this point, we've reached the open discussion point, and just want to go ahead and open up. If there are other questions, feel free to use those on chat, or go ahead and use the good old-fashioned microphone, whatever works. All right. I appreciate everyone's participation. This has been a great opportunity to be able to present some of this information, and I am right now pushing the questionnaire out to your emails. And so if you do have the opportunity to fill out the questionnaire, we would greatly appreciate it. And other than that, thank you all very much for your time.
Thank you.
Thanks, Chris. Very nice.